For today's video lesson, we will discuss about arithmetic sequence, arithmetic mean, and arithmetic series. This is part of the first quarter of the grade 10 mathematics. Then what is arithmetic sequence? It is a sequence where every term after the first term is obtained by adding a constant called the common difference. For example, 1, 4, 7, 10, 13 is an arithmetic sequence because the common difference is 3. 19, 15, 11, 7, 3 is another example of arithmetic sequence because the common difference is negative 4. 4, 12, 20, 28, 36 is also an arithmetic sequence. But can you guess if what is the common difference of this sequence? That's right. The common difference of this sequence is 8. But what is common difference? Common difference is usually denoted by letter D. It is the value or amount between each number in an arithmetic sequence. It is called common difference because it is the same or common to each number, and it is also the difference between each number in the sequence. How are we going to find the common difference? To determine the common difference, you can just subtract each number from the number following it in the sequence. Now let's try this example. 1, 4, 7, 10, 13. Let us find the common difference. So we will start with 4 minus 1, and that is 3. And 3 is our difference. To confirm if the differences of this sequence are common, let's try another one. So let's have 7 minus 4, and the answer is also 3. Next, we will have 10 minus 7. The answer is also 3. Next, we have 13 minus 10, and the answer is also 3. So if you can observe, the differences of this sequence are common, which is 3. So to get the next number after 13, we will just add this common difference 3 to 13. And that will give us 16. That is the next number. Now let's have this example. 19, 15, 11, 7, 3. Let us get the common difference. Let's start with 15 minus 19. And that is negative 4. So negative 4 is our difference. Next, we have 11 minus 15. That is also negative 4. Next, we have 7 minus 11, which is also negative 4. Next is 3 minus 7, which is also negative 4. So the common difference in this sequence is negative 4. So the next number will be 3 plus negative 4 is negative 1. Next, we have this example. 4, 12, 20, 28, 36. Let us find the common difference. Let's start with 12 minus 4, and the answer is 8. Next, 20 minus 12. The answer is also 8. Next, we have 28 minus 20, and the answer is also 8. Next, we have 36 minus 28, which will also give us 8. So the common difference in this sequence is 8. So to get the next number, we will just add 36 plus 8, and the answer is 44. Since you have now the idea on how to find the common difference and the next term, let us now try to complete the table. Given the arithmetic sequence, we will identify the common difference, the first term, and the next term. So let us try number 1. 5, 10, 15, 20. Let us find the common difference first. But to get the common difference, we need to have second term minus the first term. So our second term is 10 minus 5 equals 5. And this 5 will be our common difference. Now, our first term is 5. And the next term after 20 is 20 plus the common difference 5, that's 25. Next, 1, 3 over 2, 2, 5 over 2. Take note, 3 over 2 is 1.5 in decimals. 5 over 2 is 2.5 in decimals. So to get the common difference, we will have first second term minus first term. So that is 3 over 2 minus 1, and that is 1/2. So our common difference is 1/2. Our first term is 1, and the next term after 5 over 2 is 5 over 2 plus 1/2, which is 3. Next, 5, 2, -1, -4. So to get the common difference, we have second term minus first term, that's 2 minus 5, which gives us -3, and that is our common difference. Our first term is 5, and then our next term after -4 is -7. Next, 4, 3 and 3/4, 3 and 1/2, 3 and 1/4. So to get the common difference, we have 3 and 3/4 minus 4, that is -1/4. So that -1/4 is our common difference. Now our first term is 4, and the term after 3 and 1/4 is 3. Okay, now we need to take note this. If the list of numbers in the arithmetic sequence is increasing, our common difference will be positive. While if the list of numbers in our arithmetic sequence is decreasing, our common difference is negative. So let's have number 1. If you can observe 5, 10, 15, 20, that is increasing. So that is a positive common difference. Next, 1, 3 over 2, 2, 5 over 2. If you can observe, that is also increasing. That is why our common difference is positive. Number 3, 5, 2, -1, -4. That's positive to negative. That's decreasing. Therefore, we will have a negative common difference. Next, 4. Then it became 3 and 3/4, 3 and 1/2, 3 and 1/4. Obviously, that is decreasing. So, the common difference is a negative. What is the 30th term of the sequence 1, 5, 9, 13? So if we are going to find the 30th term, we need to list down all the possible terms. So we have 1, 5, 9, 13. We can observe that the common difference is positive 4. So to get the next terms, we will have 17, 21, 25, 29, 33, 37, 41, 45, 49, 53, 57, 61, 65, 69, 73, 77, 81, 85, 89, 93, 97, 101, 105, 109, 113, and 117. This will be our 30th term. If we are going to use this method, it will take so much time just to get the term that we want to get. That is why we will use the formula for arithmetic sequence. And this is a sub n equals a sub 1 plus the quantity of n minus 1 times d. where a sub n is the unknown term or the last term, a sub 1 is the first term, n is the number of terms or the position of the unknown term, and d for the common difference. So if we are going to solve this using the formula, we will have this. So first is use the formula. Next, substitute the values of the variables. So we have a sub n, a sub 30. Our first term is 1. And then our n, we have 30 terms. So minus 1, and our d is positive 4. Next, a sub 30 is equal to 1 plus 30 minus 1 is 29 times the 4. Now simplify, we will have a sub 30 equals 1 plus 29 times 4, that is 116. And finally, add 1 plus 116 will give us 117. So if we are going to be mastered with this method, it will not anymore take so much time to solve. Now let us use the formula in this example. What is the 25th term of the arithmetic sequence 3, 7, 11, 15, 19? So using the formula, let us now substitute. Our n is 25. Our first term is 3. So we have 25 minus 1. Our d is 4. Next, a sub 25 is equal to 3, bring down, plus 25 minus 1, that's 24 times the 4. Next is a sub 25 equals 3 plus 24 times 4 is 96. Now a sub 25 is equal to 3 plus 96 is 99. And that is our 25th term for the given sequence. Number 2. What is the 11th term of the arithmetic sequence 5, 8, 11, 14, 17? Using the formula, let us now substitute the values. So we have a sub 11, since we have 11 terms. Our first term is 5. Our n is 11 minus 1, and our common difference is 3. A sub 11 is equal to 5 plus 11 minus 1 is 10, then bring down the 3. A sub 11 is equal to 5 plus 10 times 3 is 30, and the final answer is a sub 11, which is 35. So our 11th term for this sequence is 35. For number 3, what is the 10th term of the arithmetic sequence 20, 10, 0, negative 10? So we will use the formula of the arithmetic sequence. Next, substitute the values. So our n is 10, so we have now a sub 10 equals, our first term is 20 plus 10 minus 1 times negative 10. So where do we get negative 10? That is our common difference. If you can observe, the sequence is decreasing, so we have negative. Next, a sub 10 is equal to 20, bring down, plus 10 minus 1 is 9, and then bring down negative 10. A sub 10 is equal to 20 plus 9 times negative 10 is negative 90. And lastly, a sub 10 is equal to 20 plus negative 90 will give us negative 70. And that is our 10th term. For number 4, how many terms are there in an arithmetic sequence whose first term is 7, common difference is 6, and the last term is 49? So in this problem, the missing variable is letter n, the number of terms. So we need to find the number of terms. So let us now use the formula of arithmetic sequence and then substitute. So we have 49 for our last term. And then we have first term is 7. We don't know yet the value of n minus 1. And our d, the common difference is 6. So next thing to do is to transpose 7 to the left side. And then we also need to distribute 6 to n and 6 to negative 1. So we will have 49 minus 7 equals 6n minus 6. Simplify, we have 42 equals 6n minus 6. And the next thing to do is to transpose negative 6 to the left side. So we will have 42 plus 6 equals 6n. Simplify, we will have 48 equals 6n. So to get the value of n, we need to remove the 6. So divide both sides by 6. And then 6 will be cancelled out. So what is left is n is equal to 48 divided by 6 is 8. So we have 8 as our n. So there are 8 terms in this given. Now what is arithmetic means? These are the terms between any two non-consecutive terms of an arithmetic sequence. Now example, in the sequence 3, 7, 11, 15, 19, and 23, the arithmetic means of 7 and 23 are 11, 15, and 19. Now another example, insert 4 arithmetic means between 5 and 25. So we have this illustration. So 5, 25. So we need to insert 4 terms between them. So to get the answers, we will use the formula and we just need to find the common difference in order for us to identify the terms after the given. So we have the last term, which is 25. Our first term is 5. Now our n is 6. Why do we have 6? We have 5 and 25, that's 2, plus the 4 to be inserted. So all in all, we have 6 minus 1 times the d, since we don't know yet the common difference. Next, transpose 5 to the left side. So we will have 25 minus 5, and then where did we get 5d? That's 6 minus 1, that's 5, and then bring down the d. So we have 25 minus 5, that's 20, equals 5d. So to find the value of letter d, we need to divide both sides by 5. And then cancel out 5. So what is left is d is equal to 4. So the common difference for this sequence is 4. So how are we going to get the next term? We just need to add it to 5. So 5 plus 4, we have 9. 9 plus 4, we have 13. 13 plus 4, we have 17. And 17 plus 4, we have 21. 21 plus 4 is 25. So we have our arithmetic sequence. Now, 9 is our first arithmetic mean. 13 is our second arithmetic mean. 17 is our third arithmetic mean. And 21 is our fourth arithmetic mean. Next example, what are the three arithmetic means between 3 and 11? So for this problem, I am going to present two methods. Let's have method 1. So we have 3, and then we need to insert the 3 arithmetic means, and then 11. So for this method, we will just get the average of the two terms. So we will start with 3 plus 11 divided by 2. So we have 14 divided by 2, which give us 7. So 7 will be placed in the middle part of the sequence. Next, we will find the number between 3 and 7. So just get the average. So we have 3 plus 7 and then divided by 2. That is 10 over 2. And the answer is 5. So we will place 5 between 3 and 7. Next, the missing term is between 7 and 11. So just get the average. So 7 plus 11 divided by 2. That is 18 divided by 2, and the answer is 9. So the number between 7 and 11 is 9. And these are our arithmetic means. Now, method number 2, we will use the formula for arithmetic sequence. So we have to substitute first. So our last term is 11. Our first term is 3. And then n is 5 because we have 3 and then 11 and plus the 3 arithmetic means to be inserted. And then we don't have the value of our d yet. Next is to transpose 3 to the left side. So we will have 11 minus 3 equals 5 minus 1 is 4 and then bring down the d. Next, simplify 11 minus 3 is 8 equals 4d. So to find the value of letter d, we need to divide both sides by 4. So 4 is cancelled out now. And what is left is d equals 2. And that is our common difference. So to get the numbers for our sequence, we will have 3, 11, and we need to insert 3 arithmetic means. So we will just add 3 plus the common difference, which is 2, that is 5. 5 plus 2, 7. 7 plus 2, 9. So these are the 3 arithmetic means. What is arithmetic series? Arithmetic series is the sum of the terms in an arithmetic sequence. Now we have formula number 1. So we have S sub n is equal to n divided by 2 times the quantity of a sub 1 plus a sub n. Now when are we going to use this formula? We are going to use this if the first and the last terms are given. Now formula number 2, we have S sub n equals n divided by 2 times the quantity of 2 times a sub 1 plus the quantity of n minus 1 times d. We are going to use this formula number 2 if last term is not given. Now, for our formula, a sub 1 is the first term, a sub n is the last term, n is the number of terms, d is the common difference, and S sub n is the sum of arithmetic sequence. Let us try this example. Number 1, what is the sum of the first 100 positive numbers? So this will be the illustration. 1 plus 2 plus 3 until 98 plus 99 plus 100. So we are finding the sum. Now if you can observe, first term and the last term are given. So we will use formula 1, which is S sub n equals n divided by 2 times the quantity of a sub 1 plus a sub n. Now let us substitute S sub 100. Where did we get 100? Because we have 100 terms. N is 100 divided by 2. Our first term is 1 plus our last term is 100. Now we will have S sub 100 is equal to 100 divided by 2 is 50. 1 plus 100 is 101. Now multiply 50 times 101. The answer is 5050. And that is the total or the sum of the first 100 positive numbers. Number 2. What is the sum of the arithmetic sequence 10, 5, 0, negative 5, negative 10, negative 15? The first term and the last terms are also given. So we can still use the formula 1. So S sub n equals n over 2 times the quantity of a sub 1 plus a sub n. So let us now substitute. We have 6 terms, so our n is 6. So just change 6. our first term is 10 and our last term is negative 15. Next, we have 6 divided by 2 is 3. 10 plus negative 15 is negative 5. So multiply 3 times negative 5, that is negative 15. So the sum of this sequence is negative 15. For example number 3, find the sum of the first 10 terms of the arithmetic sequence 5, 9, 13, 17. So if you can observe, we don't have our last term in this sequence. Therefore, we will use formula 2, which is S sub n equals n over 2 times the quantity of 2 times the first term plus n minus 1 times d. Now substitute the values. Our n is 10, so just change. Our first term is 5. Our n is 10 and our common difference is 4. Next, S sub 10 is equal 10 divided by 2 is 5. 2 times 5 is 10 plus 10 minus 1 is 9 and then bring down the 4. So S sub 10 is equal to bring down 5, bring down 10. 9 times 4 is 36. Next, simplify. 5 bring down. 10 plus 36 is 46. So for the final answer, we just need to multiply 5 times 46 and the answer is 230. That is the sum of the first 10 terms of the given sequence. And lastly, for number 4, find the sum of the first 20 terms of the arithmetic sequence negative 2, negative 5, negative 8, negative 11. So still in this example, we don't have the last term. So we will use formula 2. So S sub n equals n over 2 times the quantity of 2 times a sub 1 plus the quantity of n minus 1 times d. Next is to substitute. Our n is 20, so just change. Our first term is negative 2, and then our d is negative 3. Simplify. S sub 20 is equal to 20 divided by 2 is 10. 2 times negative 2 is negative 4 plus 20 minus 1, that's 19, and then bring down negative 3. Next, just simply bring down S sub 20 equals bring down 10, bring down negative 4, and then 19 times negative 3, that's negative 57. Next, S sub 20 is equal to bring down 10, negative 4 plus negative 57. So we will have negative 61. And lastly, just multiply 10 times negative 61 will give us negative 610. And that is the sum of the first 20 terms of the given sequence. There you have it mga kamat peeps, and we are done discussing about arithmetic sequence, arithmetic mean, and arithmetic series. Thank you for watching, and I hope you have learned something from our video lesson today. Until next time, goodbye!